This is SpaceTime Series 25, Episode 53, for broadcast on the 11th of May 2022. Coming up on SpaceTime, why the moon's near and far sides look so different. After a 3-year shutdown, the Large Hadron Collider restarts operations. And a busy time aboard the International Space Station, with the Axiom astronauts departing as the Crew 4 mission arrives. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study supports earlier claims that the dichotomy between the lunar near and far sides was caused by a colossal ancient impact billions of years ago. Astronomers have long puzzled about the differences between the two faces of Earth's moon. The lunar near side, that's the one which always faces the Earth, is relatively low and flat, with many large dark basalt mare, vast dark-coloured remnants of ancient lava flows. Meanwhile, the far side of the moon, which always faces away from the Earth, is heavily cratered with high mountainous terrain, a far thicker crust, and is virtually devoid of any large mare features. Why the two sides of the moon are so different remains one of science's enduring mysteries. The new hypothesis, reported in the journal Science Advances, suggests that a giant impact event which created the moon's South Pole Aitken Basin also generated a huge plume of heat which propagated through the lunar interior. The authors propose that that plume would have carried numerous materials with it, including a suite of rare earth and heat-producing elements which all would have eventually found their way to the lunar near side. The study's lead author, Matt Jones from Brown University, says that concentration of elements would have contributed to the volcanism which created the near-side volcanic plains. Big impacts like the one which formed the South Pole Aitken Basin would create lots of heat. Jones says the question is how much that heat affects the moon's internal dynamics. Under the conditions at the time the South Pole Aitken Basin formed, the internal dynamics ends up concentrating these heat-producing elements on the lunar near side. And he says that contributed to the mantle melting, which helped produce the lava flows seen on the near side surface. The differences between the near and far sides of the moon were first revealed in the 1960s by Soviet lunar missions and the American Apollo program. While the differences in volcanic deposits are easy to see, future missions would reveal differences in the geochemical composition as well. The near side is home to a compositional anomaly known as procelarium creep terrain, or PKT, a concentration of potassium, rare earth elements, phosphorus, and heat-producing elements like thorium. Creep seems to be concentrated in and around Oceanus Procelarium, the largest of the near-side volcanic plains, but it seems to be fairly sparse elsewhere on the moon. Now, scientists have previously suspected there was a connection between the procelarium creep terrain and the near-side lava flows. But the questions remained exactly why was that suite of elements concentrated only on the near side? This new study provides an explanation that is connected to the South Pole Aitken Basin, the second largest known impact crater in the solar system. For the study, the authors conducted computer simulations of how heat generated by a giant impact would alter patterns of convection in the moon's interior, and how that might redistribute creep material in the lunar mantle. Creep's thought to be the last part of the moon's mantle to solidify following its formation 4.5 billion years ago. Now, according to the giant impact theory, a Mars-sized planet called Theia slammed into the early proto-Earth about 4.5 billion years ago, turning both bodies into a magma ocean, which would eventually meld together, coalescing to form the Earth. But not all of that material went into making the new planet. Some debris was ejected into orbit around the planet. It eventually coalesced to form the moon. Now, under this scenario, as the moon differentiated and solidified, creep likely formed in the outermost layer of the mantle, just beneath the lunar crust. Now, previous models of the lunar interior suggested this should have been distributed more or less evenly beneath the surface. But the new model shows that this uniform distribution would have been disrupted by heat plumes from a massive impact. According to this model, the creep material would have simply ridden the wave of heat emanating from the South Pole Aitken impact like a surfer. And as the heat plume spread beneath the moon's crust, this material was eventually spread en masse onto the near side. To confirm their hypothesis, the authors ran numerous simulations from a number of different impact scenarios, including a dead-on hit right through to a glancing blow. While each produced a differing heat pattern and mobilized creep to varying degrees, all created creep concentrations on the near side, consistent with the Procelarium creep terrain anomaly. The authors believe their work provides a credible explanation for one of the moon's most enduring mysteries. Exactly how the Procelarium creep terrain formed is arguably the most significant open question in lunar science. And the South Pole Aitken Impact Basin is one of the most significant events in lunar history. This work has managed to bring the two together, tying them up in a neat little package. The new study follows on from earlier hypotheses which claimed that the Earth may have once had two moons, which eventually crashed together, forming our current celestial partner. That hypothesis, reported in the journal Nature a decade ago, was based on computer simulations undertaken by planetary scientists at the University of California, Santa Cruz. Their work suggested that the lunar farside highlands are actually the solid remains of a collision with a smaller companion moon. The study suggests that the Theia impact actually created two blobs of ejecta, which formed two moons orbiting the Earth, one larger and the other much smaller. It suggests that the pair eventually collided, with the smaller one coating one side of the moon with an extra layer of solid crust tens of kilometres thick. The Santa Cruz researchers say a slow, low-velocity impact collision wouldn't form an impact crater or cause much melting, but would instead pile onto the impacted hemisphere as a thick new layer of solid crust, forming a mountainous region just like the lunar farside highlands. The authors hypothesized that the companion moon was initially trapped in a gravitationally stable Trojan point, but it became destabilized after the moon's orbit expanded away from the Earth, something the moon's still doing today at a rate of about 3 centimeters per year. The impact would have made the moon lopsided and reoriented it so that one side faces the Earth. Their model also shows the impact squishing a molten subsurface layer over the opposite, that is, Earth-facing side of the moon as well. This is SpaceTime. Still to come, the Large Hadron Collider restarts operations after a break of over 3 years, and the Axiom Space Ax1 crew return to Earth following their visit to the International Space Station. All that and more still to come on SpaceTime. The world's largest atom smasher, the Large Hadron Collider at CERN, is once again sending beams of proton packets around its 27-kilometre underground ring. The restart of the giant particle accelerator 100 metres below the Franco-Swiss border near Geneva ends more than 3 years of upgrades and maintenance work at the facility. Beams of protons injected at 450 billion electron volts are now being sent in opposite directions around the ring, guided by cryogenically cooled superconducting magnets at speeds of 99.9999% the speed of light. In physics, an electron volt is a basic unit of particle energy. It's the amount of energy gained or lost by a single electron accelerating from a position of rest through an electric potential difference of 1 volt in a vacuum, which equates to about 1.602 by 10 to the minus 19 joules. By comparison, the energy of visible light ranges from about 2 to 3 electron volts. And thanks to Albert Einstein's famous mass-energy equivalence equation equals mc squared, that is, energy equals mass times the speed of light squared, the electron volt also acts as a unit of mass in physics and astronomy, with 5.60958835718 times 10 to the 35 electron volts to a kilogram. The Large Hadron Collider is part of a large complex of particle accelerators, synchrotrons and other high-energy laboratories located at CERN, the European Organisation for Nuclear Research. Rudy Jones, the head of CERN's Beams Department, says the first round of high-intensity, high-energy collisions are still several months away. But the first beams going round the ring represent the successful restart of the accelerator after all the work carried out during the extended shutdown. CERN's Director of Accelerators and Technology, Mike Lamont, says the machines and facilities underwent major upgrades during the shutdown, which included an extensive consolidation program, and they'll now run at even higher energies thanks to major improvements to the injector complex. So, this will deliver significantly more data for the Large Hadron Collider's upgraded experiments. While pilot beams did circulate around the collider for a brief period in October last year, the beams that are circulating there now mark not only the end of the second shutdown of the collider, but also the beginning of 4 years of physics data collecting, which is expected to start around the middle of the year. Until then, scientists and engineers will work around the clock to continue progressively recommissioning the machine and safely ramp up the energies and intensity of the beams before delivering collisions to the experiments at what will be a record energy of 13.6 trillion electron volts. The third run of the collider, called Run 3, will see the machine's experiments collecting data from collisions not only at record energies, but also in unparalleled numbers. The Atlas and CMS experiments can each expect to receive more collisions during the physics run than the two previous physics runs combined. With the LHC-B experiment, which underwent a complete revamp during the shutdown, now hoping to see its collision count increase by a factor of 3. And the ISS experiment, a specialised detector for studying heavy ion collisions, can expect a 50 times increase in the total number of recorded ion collisions thanks to the recent completion of a major upgrade. The huge number of collisions that will be taking place under Run 3 will allow physicists from around the world to study the Higgs boson in greater detail than ever before, and to put new constraints on the standard model of particle physics, which is the foundation of science's understanding of the universe. Other things to look forward to during Run 3 will include the operation of two new experiments, FASTER and SEND at LHC, which are designed to look for physics beyond the standard model. Special proton-helium collisions designed to measure how often antiprotons, that's the antimatter counterpart of the proton, are produced in these collisions, and collisions involving oxygen ions that improve science's understanding of cosmic ray physics as well as the quark-gluon plasma, the state of matter that existed shortly after the Big Bang 13.82 billion years ago. This is SpaceTime. Still to come, SpaceX's Axiom Ax-1 crew returned to Earth from the International Space Station, just as another SpaceX rocket launches, this one carrying crew 4 astronauts to the orbiting outpost. Busy times indeed. All that and more still to come on SpaceTime. The SpaceX Axiom Ax-1 flight to the International Space Station has ended safely, with the team splashing down in the North Atlantic Ocean off the coast of Florida. The return of the first all-private flight to the orbiting outpost was delayed by a week due to bad weather conditions in the splashdown zone. The 4 scientists and engineers on board commenced their deorbit burn a day after undocking from the space station, with a splashdown occurring 38 minutes later.
So they undocked from the International Space Station yesterday at 9:10 p.m. Eastern. The Dragon capsule performed a couple of maneuvers to basically line everything up in preparation for re-entry. We jettisoned the Dragon trunk to expose the heat shield, and we closed the nose cone after performing a deorbit burn, which was the final burn. That's the burn that locked us in, committed us to splashdown today. So once that burn was concluded, we shut the nose cone, locked it up, and now the crew is just waiting to come back home.
In the lead up to today, SpaceX has selected primary and alternate splashdown locations off the coast of Florida.
Splashdown on either side of the Florida Panhandle. We have 2 identical and fully equipped recovery vessels ready to support, one in the Gulf of Mexico and the other in the Atlantic Ocean.
The selection process takes into account a lot of different variables, including what landing sites are available and which have favorable weather. High winds, some rain, it's all been a challenge, but that's why we have redundancies, right? So, today our primary landing site gets the crew home off the coast of Jacksonville, Florida. And for return, we'll be looking at a number of weather items. Some of the obvious ones are no rain or chance of lightning in the recovery zone, both for the safety of the crew inside the capsule and also the recovery teams on the water that assist crew. So we're also looking for wind speeds less than 15 feet per second or about only 10 miles per hour and relatively calm seas. So it's a pretty precise place you need to splash down in. So that we can safely execute recovery operations, which includes landing a helicopter on the recovery ship to fly our crew back to shore.
All right, blackout start is predicted at 16:53:04 and blackout end at 16:59:40. How copy?
I copy start 165304 and end 165940.
Good copy.
All right, so we got an update on our blackout period. We're waiting to see if we get comms back.
Loud and clear, Sarah. Crew's doing fine.
There we go.
Copy that. Great to hear from you.
Right on time, about 10 seconds early here.
All right, there we heard the voice of Commander MLA Michael Lopez Alegria. They're just confirming that the crew, they're doing good.
Right on schedule, too.
The external temperature of the capsule is about 3,500 degrees as it makes its way through the Earth's atmosphere, but the crew, they're comfortable inside.
Dragon, you can expect automated parachute deploy at standard altitude.
Copy that, Sarah.
All right, so just a heads up there to the crew that they can expect to feel those initial drogue parachutes deploy.
Right. Dragon then deploys its drogue parachutes to stabilize and decelerate the vehicle.
Now, just before the deployment of those drogue parachutes, seats automatically rotate 26 degrees to keep the crew within acceptable G limits for entry and landing. Without the drogue chutes, we would have to make the mains 3 times stronger and heavier. And of course, everything about spaceflight is about weight.
Right.
So if
Dragon SpaceX, brace for drogue window.
vehicle's velocity at drogue deployment is about 350 miles per hour. And they deploy at about 18,000 feet.
From that deploy, it's a pretty quick succession of events, right? We deploy the drogues very quickly after. There we go. There we go. You're seeing the drogues deploy now.
Live view from onboard Dragon Endeavour of those drogue parachutes. Capsule's going about 350 miles per hour.
Nominal descent rate for 2 healthy drogues.
Copy, sir.
All right, mains will be coming out here in...
That's what you love to hear from inside the capsule.
Exactly.
Because unfortunately they can't
20
see the parachutes, so to hear that call out that their drogues are healthy, it's great news.
So the mains come out at about 6,500
and
feet.
having that single voice of the core, talking to crew, letting crew know that they're going into a planned LOS, and then coming back. All right,
There we go.
there's the 4 mains deploying.
Looks like we got 4 mains. Just need to see them disreef there.
All right, so
We have visual on 4 mains.
So there we heard that confirmation of 4 mains deploying.
And descent rate nominal.
Look at that, all
Gorgeous
4 of them
shot
coming out.
Of those 4 main parachutes.
1,000 meters.
Copy 1,000 meters.
So just the crew reporting that they're only 1,000 meters from splashdown.
Right.
Landing in water is simpler, therefore more reliable, and it provides more margin against unlikely parachute issues. You know, we had to learn how to make Dragon
love this
waterproof, but once you do, that's it. It's a rinse, review, reuse type process.
It looks so...
800 meters.
Copy 800.
About 2 minutes to landing or so.
Once again, our Axiom 1 crew is targeting a splashdown in the Atlantic Ocean at our Jacksonville recovery zone. The recovery teams are in the area waiting for that splashdown confirmation.
Scheduled for about 2 minutes from now, according to our clocks.
600 meters.
Copy 600.
200 meters, bracing for impact.
Copy bracing.
And right now, I think those parachutes slowed the vehicle down to about
15 miles per hour. Yep. As you can tell by the cheers behind us, we can confirm that the Dragon capsule with the Ax1 crew has splashed down. Dragon Endeavour has returned home with the Axiom 1 crew.
Dragon SpaceX, we see splashdown and mains cut.
The SpaceX recovery ship and team has been waiting for Dragon splashdown, and they're now making their way to that location.
On behalf of the entire SpaceX team, welcome back to planet Earth. The Axiom 1 mission marks the beginning of a new paradigm for human spaceflight. We hope you enjoyed the extra few days in space, and thanks for choosing to fly with SpaceX.
The Ax1 Flight was designed to pave the way for Houston-based company Axiom Space to eventually develop its own orbital space station. Unlike previous space tourism missions, the private Ax1 crew spent more than 1,000 hours training up for the flight. and most of their time on station was dedicated to conducting specific research designed to help better explain microgravity's effects on the human body. Axiom plan to build their orbiting space station by launching their own research and habitation modules, which will initially be attached to the International Space Station. And eventually, once they have enough modules up there to be self-sufficient, they'll detach and move into their own separate orbit. The start of a brave new world. This is SpaceTime. Still to come, NASA's SpaceX Crew 4 arrives at the International Space Station, and later in the science report, a new study looks at what your cat really gets up to when he or she goes outside. All that and more still to come on SpaceTime. Just a few days after the Axiom Ax-1 team left the International Space Station, NASA's SpaceX Crew 4 Dragon capsule successfully docked to the orbiting outpost Harmony module, bringing new crew members aboard. The crew had launched 16 hours and 23 minutes earlier from Pad 39A at the Kennedy Space Center at the Cape Canaveral Space Force Base in Florida.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition and liftoff. Go Falcon. Let freedom ring. Godspeed, Crew 4. Vehicle is pitching downrange. Copy 1 Alpha.
Freedom soars and the Dragon flies forth. Vehicle already pitching downrange. All 9 Merlin engines have lit.
Stage 1 propulsion is nominal.
Getting good performance on stage 1 propulsion already.
We are T plus 35 seconds into the 4th rotational crew mission on board Dragon and the Falcon 9. The 9 Merlin 1D engines on the first stage are beginning to throttle down.
Stage 1, throttle down.
In preparation for MaxQ. This is where the vehicle will experience the highest amount of aerodynamic pressures, so we'll throttle down the engines in preparation for that event.
Vehicle is supersonic.
All right, so we've passed the speed of sound.
MaxQ.
And there's our call out for MaxQ.
Stage 1, throttle up.
So right after MaxQ, we will begin to throttle those engines up again.
Copy 1 Bravo.
1 Bravo, so we're in the second and final abort mode for the first stage. Continuing to get good performance though. The crew already pulling in excess of 2 Gs. And coming up next is going to be a couple of events in rapid succession.
Yep, in about 10 seconds here, we're going to be performing engine chill on the second stage MVAC engine. And then in about a minute, we're going to start off with MECO, also known as main engine cutoff. This is where those 9 engines, those are going to cut off in preparation for stage separation, where the first and second stages will separate from one another, and then the single Merlin vacuum engine on the second stage will ignite and continue to carry our Crew 4 astronauts to orbit.
We heard that MVAC chill has started.
Stage 1, throttle down.
The 9 Merlin engines starting to throttle down.
And MECO.
Stage separation confirmed.
We see that second stage engine light. We're in 2 Alpha, the second abort mode. The second stage is lit, continuing to carry the Crew 4 astronauts onto orbit.
So right now, the first stage is making its way back to Earth to attempt its 4th landing on our drone ship, a shortfall of gravitas. The crew, they are continuing with their journey to outer space.
Good performance on that lone Merlin vacuum engine on the second stage. The crew's G-load dips right when we hit that separation event, and it's going to continue to build up now. Just heard acquisition of signal Bermuda. That means we're
Dragon,
now...
SpaceX, nominal trajectory.
Freedom copies, nominal trajectory.
That was our guidance, navigation, and control officer. Nominal trajectory. Dragon's pointed in the right direction, continuing its flight to orbit. We heard Bermuda called out. That's one of the ground stations now receiving telemetry from the Dragon as it continues its path uphill.
The first stage has a couple of events itself in order to land on a drone ship. So at T plus 7 minutes and 25 seconds, it's going to start its entry burn. It's going to be one of 2 burns. This is where 3 of the 9 Merlin
Dragon,
engines
SpaceX, nominal trajectory.
on the first stage will relight and burn for about 30 seconds in order to slow the vehicle down before hitting the denser parts of the Earth's atmosphere.
Acquisition of signal, New Hampshire.
All right, now on the New Hampshire ground station, another call out there from our guidance, navigation, and control officer, nominal trajectory. Second stage continues to power. Call out just then, propulsion is nominal, the engine performing as expected. Crew pulling a little more than 1.25 Gs right now. Again, that's going to continue to ramp up, peaking just before we get to that second stage cutoff.
Yep, this single engine here, Dan, can produce over 220,000 pounds of thrust in the vacuum of space, so they are definitely feeling it.
We're already about 200 kilometers in altitude.
Dragon, SpaceX, nominal trajectory. Freedom copies, nominal trajectory.
Great call out that we are headed in the direction that we need to, and we just heard from Chell, the commander.
We should get one more of those trajectory check-ins in about 30 seconds from now, and then we'll start to hit our events in rapid succession as the first stage continues to make its way back home. The second stage will start to wrap up its job of delivering these astronauts into orbit.
Dragon, SpaceX, nominal trajectory. Stage 2, flight termination system.
So for those just joining us, we are
entry burn startup.
just under 8 minutes into flight. We have 4 astronauts as part of the Crew 4 operational mission. This is our first stage with 3 of 9 Merlin engines reignited and slowing down the first stage before we hit the denser parts of the Earth's atmosphere. So this first stage has one more burn left.
Burn shutdown.
That's going to happen just before the T+9 minute mark, and then we'll attempt a landing for the 4th time on our drone ship that's currently parked in the Atlantic Ocean.
So as that entry burn completes,
Terminal guidance.
we're in the final stages of the second stage's flight into orbit. We're about to pass through several of the different abort phases, which essentially correspond to areas along the very northeastern seaboard of the U.S. and then across the Atlantic and off the coast of Scotland. But continuing to get call-outs that stage 2 propulsion is nominal.
Copy, Shannon.
And the call-out of Shannon, Ireland, that's
Stage 1 transonic.
indicative of our final abort zone.
And after this second stage engine shuts off its engine, we are going to be listening for the confirmation of a good orbit, which tells us that the crew and Dragon are where they need to be in
Stage
orbit.
1 landing burn. Dragon, SpaceX, nominal orbit insertion.
And that was the call out that we wanted on the second stage
We're glad to be in orbit.
of the first stage.
SpaceX launch escape system is disarmed.
Landing legs have been deployed, returning back to Earth for a 4th time. Just like that, a 4th landing as part of the Crew 4 mission. You can hear the applause behind us. But prior to this,
Acquisition of signal, Newfoundland.
we heard that the crew has been successfully inserted into a good orbit.
They're still attached to that second stage, which at this point is going to continue to coast for a couple of minutes. It's got small reaction control thrusters on the upper part of the second stage that can be used to cancel out rates, essentially making sure that they're on a stable coast before we get to that separation event, after which we'll see Dragon Freedom flying free for the first time.
The new team members will join the existing Expedition 67 crew already on station, focusing on microgravity experiments, material science, health technologies, plant science, and research, hoping to prepare for longer duration space flights, both to the moon and eventually onto Mars. The Crew 4 mission also marked the 5th SpaceX flight with NASA astronauts, including the Demo 2 flight back in 2020 to the space station, which are all part of the agency's Commercial Crew program. The other half of that program, Boeing's Starliner spacecraft, has been beset with ongoing delays. However, the latest word is an unmanned flight to the space station is likely to take place as soon as May 19. We'll let you know. Meanwhile, the SpaceX Crew 4 flight was also the 3rd commercial crew mission to fly an ESA astronaut. Italian Samantha Cristoforetti will take over from German Matthias Maurer and be responsible for operations within the US orbital segment of the space station, which comprises American, European, Japanese, and Canadian modules. This report from ESA TV.
Exciting days lie ahead for ESA astronaut Samantha Cristoforetti aboard the International Space Station, ISS. Known as Minerva, the Italian ESA astronaut launched to the station from NASA's Kennedy Space Center in Florida in a Crew Dragon spacecraft. For her first mission, Futura, which was provided by the Italian space agency ASI and began in 2014, Samantha flew to the ISS on a Soyuz vehicle.
Regarding the vehicle, the training experience has been definitely quite different. On Soyuz, I was a flight engineer, so sort of like a co-pilot. I had a very deep knowledge of the systems, and I was a full backup of the commander for all the tasks on board. On Dragon, I will be a mission specialist, so I will not have a direct interaction with the systems on board. That will be a responsibility of my two crewmates, Chell and Farmer. So my training load was a lot smaller in this case.
Like all ESA astronauts, Samantha will carry out many scientific experiments on the ISS and within the European Columbus laboratory. The space station's weightless environment provides opportunities for research that is not possible on the ground. The name of Samantha's second mission, Minerva, is inspired by the Roman goddess of wisdom, handicrafts and the arts. It's a homage to the competence and craftsmanship of all those who make human spaceflight possible. The name also represents the traits Samantha attributes to human spaceflight.
I also like to play with words, and for each letter that makes up the name Minerva, I can think of a word with that initial letter that gives context and meaning to my flight to space, but in a broader sense to human space flight. So M for marvel, I for inspiration, N for nourishment, which can be physical nourishment, but also spiritual nourishment. E for exploration, R for research, V for voyage, and A for adventure.
The theme of exploration, voyage, and the human achievements of spaceflight are also echoed in Samantha's new mission patch, which features Minerva's sacred owl. The eye of the owl is a yellow moon casting a white glow onto Earth. Its beak is reminiscent of the shape of the International Space Station, while the two lines also symbolise Samantha's two missions to space. The owl's body is made up of waves of ever darker blue, encouraging humankind to rise to the challenge as we move further into deep space. An ambition Samantha shares.
Yeah, I'm very excited, of course, about the next program of human space exploration, the Artemis program. ESA plays a major role in that we provide the service module for Orion, for the spaceship that will bring astronauts back to the orbit of the moon. And I really hope that this is just the beginning, and that Europe, the countries and the member states of ESA and ESA will be more and more ambitious when it comes to capabilities regarding human spaceflight, so that we can be more and more in the future equal partners as we expand our presence in space.
This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new study has found that at least 7 different physical properties or characteristics of the body, which are known as phenotypes and are partly the result of genes and partly the result of your environment, can help people avoid catching or suffering severe illness from COVID-19. The newly identified phenotypes reported in the journal Nature are all associated with regions of the genetic code that reduce the risk of COVID-19 infection. Scientists surveyed 700,000 people about their COVID-19 outcomes to look for patterns in genetics and phenotypes among those who had come through the pandemic relatively unscathed. The authors say the results confirmed 4 previously identified phenotypes which were associated with lower risk of severe COVID-19, as well as 3 new phenotypes associated with avoiding COVID-19 infection after household exposure and experiencing fewer symptoms. Over 6.3 million people have now been killed by the COVID-19 coronavirus since it first appeared in the area surrounding China's Wuhan Institute of Virology back in September 2019. However, the World Health Organization says the true death toll is now likely to be at least 15 million, with well over 500 million confirmed cases globally. Paleontologists have discovered fossils representing 3 new ichthyosaur species which may have been among the largest animals to have ever lived. The discovery, reported in the Journal of Vertebrate Paleontology, consists of a range of skeletal remains, including the largest trunk vertebrate ever found in Europe. This demonstrates an ichthyosaur rivaling the largest marine reptile fossil known today. Also uncovered is the largest ichthyosaur tooth ever found. The width of the tooth is twice as large as any aquatic reptile known previously, with the previous largest belonging to a 15-metre-long ichthyosaur. These monstrous 80-ton reptiles look like giant dolphins and would have patrolled Panthalassa, the world ocean surrounding the supercontinent Pangaea, during the late Triassic about 205 million years ago. The new discovery shows that they also made forays into the shallower waters of the Tethys Sea, an archipelago on the eastern side of Pangaea, in what is now Europe. The most extensive study of its kind ever undertaken has found that one of the most popular house pets, the domestic cat, seldom strays far from home. The findings, reported in the journal Scientific Research, show that our feline friends spend an average of 79% of their time outdoors but within 50 metres of their home, with the average maximum distance being no more than 352 metres. The study was undertaken by the Norwegian University of Life Sciences. Researchers used GPS tracking to follow the movements of every one of the almost 100 pet cats that lived in a small Norwegian town in the country's east. The domestic cat, Felix domestica, is one of our most popular pets. In Norway alone, some 5.4 million people own approximately 770,000 cats. The goal of the study was to map the movements of an entire population of pet cats within the same area. The results, which mirror similar studies in other European countries, show that cats have very different personalities, with some travelling great distances, some as much as several kilometres, but those were the exceptions. Most cats are literally just around the corner in the garden when they're outside. Importantly, almost all the cats in this study had responsible owners who have already had their pets desexed, something which stops them from roaming too far from home. Well, it looks like one part of the political landscape has gone into absolute outrage overdrive in the wake of Elon Musk's $44 billion bid to take over social media giant Twitter. Insults and outrageous claims are flying thick and fast as those who've long considered Twitter as their own private sounding post are in despair at the possibility of being forced to allow balanced and free speech onto a platform which has long had a history of cancel culture towards any view which doesn't match their own. The Russian collusion scandal and the Hunter Biden laptop are just two examples of truth being suppressed by Twitter. So, the outrage is not so much about the right for free speech as much as it is about the right of who should be heard. With the details, we're joined by technology editor Alex Zaharov-Reutt from ITWire.com.
Is Elon Musk, I've been asked the question, did he buy it to make a profit, or did he buy it so he could have the power of owning his publishing platform? And I sort of thought to myself, well, obviously it's both. I mean, clearly the man knows how to make money. He knows how to make successful products. But there's no reason why he wouldn't want to unlock the potential of Twitter, as he put it. Twitter has a lot of competition from Facebook, from the internet at large, from every local radio and TV station, from Parler, from Getter, from Trump's own Truth Social. Will Trump go on to Twitter? At the moment, he's saying no. I mean, why would he? He's got Truth Social. I was going to call it Trump Social. But that Truth Social is only available in the US. Can't get it in Australia or other countries, at least not yet. And Twitter has this undeniable power and pull. And I know that in the past, when I've heard about earthquakes in Melbourne a few years ago, the first place I looked was Twitter to see if other people were reporting that.
Well, that's the way journos use it. We use Twitter as an informal wire service to give us the breaking news. Then we go to more formal sources to verify it. That's how Twitter's worked. And it doesn't just do that for journos. It's become a portal for politicians. And from there, it's moved on to the wider community, not just as a gossip place where you can find out about the latest goop that Gwyneth Paltrow is selling or what a grump he is in Johnny Depp's boudoir, but it's the town square that people talk about.
And look, Trump used it very successfully to disseminate his information direct to the people, as it were, although Twitter was the intermediary. And Trump has tried to create that same conduit, both on his own site, only since the last few days, and now with Trump Social. So, there's definitely power there to be able to connect with people. And Twitter has abused that power by blocking people, by banning people.
Yeah, how do you ban the President of the United States, but not the leaders of the Taliban or Islamic State or Vladimir Putin, for that matter?
Yeah, incredible
unbalance there. That's just wrong.
Incredible hypocrisy on the behalf of Twitter. And, there's no balance. So hopefully Elon Musk will be like Luke Skywalker and bring balance back to the Force. We hope that he doesn't turn into Darth Vader, and we hope that he remains a very balanced person and truly does promote free speech and guards it. We want to see the Twitterverse become more open. I heard on a report that only 20% of Americans are using Twitter, which means 80% are not. There's a vast, huge, untapped potential.
But it's that 20% that are using Twitter that are the influential 20%. It's like only 5% of Australians listen or watch the ABC, but the ABC still dictates the agendas of the day.
Well, to a certain audience, Sky News has made great strides in restoring some of that balance. But, Elon Musk himself put out a tweet noting that some of the top followed people on Twitter, Justin Bieber or Taylor Swift or others, there was a list, I can't remember who else was on that list. He was on that list.
I'm not
but
on
many
that
of
list,
those people, no, I'm not on that list either, but many of those people hadn't tweeted for months. And he was sort of saying, you can see that Twitter is, for some at least, losing its power, losing its luster. And Twitter has not had the growth trajectory or potential realized that somebody like, an organization like Facebook has, for example, which pretty much everybody's on Facebook, but plenty of people are on Twitter. And there are many examples where Twitter is the equivalent of the back door of a public toilet with stuff scrawled on there that journalists use to somehow prove points in their articles, which is not really the best use of Twitter. Twitter has been an open source intelligence, something we've heard, OSINT, something we've heard about a lot in the Ukraine war, where people can report those things like the earthquakes and like other local information that previously was impossible to be able to get. And then, of course, as you say, you get the geological organization, confirming that there was a X number on the Richter scale.
Now, you mentioned Facebook a moment ago, and that brings up something that Meta's doing. Tell us about that. They've opened their own shop.
Yeah, that's right. Well, if you think
what do they
Facebook
sell?
Well, that's right. Meta, what are they selling in their retail store? They're already selling all that data, so it obviously can't be that. Obviously, Meta has a bunch of hardware. They have the Portal, which is effectively their version of FaceTime on an iPad or an Alexa type device that sits on a tabletop. They have the Ray-Ban Stories, a pair of glasses that what will one day turn into augmented reality glasses, I guess. And they have the Oculus Quest 2, which they've renamed the Meta Quest 2, which is their virtual reality glasses. And so this is their first physical retail space in their campus in Burlingame in California. And obviously, you'll be able to get hands-on experience with all of their hardware products. So they've got interactive demos. You can make video calls to what they're saying is retail associates with the Portal. You can learn how Ray-Ban Stories can help you stay present with the world around you, which is, again, augmented reality, or the potential of that, because it really hasn't quite been delivered in that regard. But of course, with VR, it has been delivered. We obviously have HTC Vive, and we have the full-on Oculus devices that connect to PCs. But then you have the portable devices, which are a all-in-one device. You used to previously have to put a phone into a pair of glasses. Samsung tried to do that with their Oculus Gear VR headset in 2016. Google tried to do something similar with its headset, but it's really the Oculus Quest 2. I think HTC has one as well, but the Oculus Quest 2 is kind of the one of the moment. I recently purchased one. Someone had one on Gumtree for $250, and I bought it, and it's pretty amazing. You stick it on there. Personally, I would prefer augmented reality glasses, but it is a nice experience to play these various games and to
For our
have
listeners, just explain the difference.
Well, virtual reality puts you into a world which is cut off from the rest of the world. You cannot see or interact with the outside world. In virtual reality, you are in the spaceship, you are in the desert, you are wherever you are in that experience.
Very addictive too, I might point out.
Yeah, and there have been movies like the movie Surrogates with Bruce Willis when he was still making good movies, where you controlled a robot and you were plugged into the seat and you were seeing the whole universe or the world as it was. That was a kind of a blending of both virtual and augmented reality. But augmented reality is where you put on a pair of glasses and suddenly overlaid onto the actual reality you are seeing. There is information. So you might see in a corner a video call, you might see weather, you might see directions on the road that are guiding you, whether you're walking, driving, or riding a bike to your next destination. If you go to a party and you see somebody you haven't seen for a while. Yeah, the Terminator, that sort of thing. So you go to a party, you see somebody you haven't seen for a while, and it says, well, their name is Jack, their spouse is named Karen, they've got 3 kids, and it's reminding you of all the information. So augmented reality glasses are something that future generations, possibly within the next 10 years, will be wearing almost permanently. And if you don't have that link to the digital world, you won't be able to interact with the modern world as we know it. And there will be people who will not want to be part of it at all. They'll want to live a primitive life, and others will be even more addicted to this way of seeing the world than they are already looking at their glowing rectangles of glass.
That's Alex Zaharov-Reutt from ity.com. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.